In this session, we are going to discuss the classification algorithm in the machine learning. Basically, the classification is a supervised type of machine learning algorithm where the input patterns and output patterns both are known. So the task which we are going to perform, that is the classifier or the classification. So in the various projects, various case studies nowadays, we require a classification. We require for the various business trends also, there is a need of the classification algorithm. So that's why we are using the classification algorithm in the machine learning, and we are going to see the practical approach of the same. Okay, so first of all, I'm going to the Python file for the classification algorithm. So the classification, it generally, as the name suggests, it will classify the various contents of the database. Okay, so here, first of all, we have to import various libraries for the classification algorithm like NumPy, Pandas for reading the database. C1 is actually useful for the visualization and the various graphs. Okay, then scikit-learn, various machine learning algorithms, they are already inbuilt in the scikit-learn library. Matplotlib, it is useful for plotting the graphs. So we are going to import these libraries. Okay, so first of all, we have imported them. Then the next thing is to read the database. We have already uploaded a database of Indian liver patients in a CSV file format. Okay, so I'm going to import the same using the syntax pd.read underscore CSV and the file name. Okay, and as I have given the various commands like data.info and data.describe, what it will do, it will show the information and the description of the database. You will see here. This database, it has a 583 entries and the total 11 columns. So that will show with the help of the data.info and data.describe functions. Also, with the help of the data.head function, see this one, data.head function, you can describe the various columns and the rows of the particular database in this way. By default, it will show first 5 rows. If you want to show more rows, so you can put the values there. Suppose we want to show the 10 rows. So in this way, it will show the 10 rows. Okay, if you want to show the final rows also, suppose it is from 352, you can show the same rows also, but by default we can show the 5 rows using this function. Then the next thing in the pre-processing, whether the outliers or the missing terms are present in the database, that should be detected and that should be removed by using some methods. Okay, so that is called as the null value. So that data underscore null equal to data dot is null. That is the syntax that we are using here to show the null values. Okay, if there are the null values, that will be determined. Okay, and that will be this issue will be resolved. Okay, so here the issue of the null values is resolved now. We are using the mean. Okay, mean, median, these are the methods to resolve the null values. We have used the mean method. Okay, the next is check once again whether the null values are there or not using the syntax data dot is null function dot sum function. Okay, so that will show, you can see the various columns all represent the zero value, means there is no any null value or the outlier present in the database. Now our database is fully ready for the analysis. Now the next thing is to concatenate the data. You can also concat the data using this syntax or the command concat. Okay, so this will concat the various databases also. So next is a data dot correlation. We can find out the correlation between the data. Then we can show using the data dot info also. Now we have to avoid a few columns like direct bilirubin and the SCOT, which are not important for our particular analysis. You can also delete them. Okay, you can delete them. So data correlation dot head, it will show the data correlation. Then we have to use the scikit-learn model. Okay, so to get the confusion matrix as well as the accuracy score, and for the training and test data splitting also. So now here we are using the various classification algorithms like the logistic regression and the decision trees. Okay, but the linear regression is not a classification algorithm. Linear regression is the regression type of algorithm. Logistic regression, it falls under the classification algorithm category. So here the logistic regression we are going to execute for the classification model. So from the scikit-learn, we are going to import the logistic regression class, then the dependent variables and independent variables from the liver patient database. From that, we are going to show whether the patient is a liver patient or not. So using the value binary value 0 and 1, we have to show the dependent and independent variables here. Okay. So here we'll get the value. Okay, that is the logistic regression. Okay, so in this way you can find out the accuracy and the prediction using the classification algorithm.